product of two or more fractions is a fraction whose numerator is the product of the numerators of the original fractions and whose denominator is the product of the denominators of the original fractions. So for instance, 2 over 3 times 5 over 7, 5 times 2 is 10, 3 times 7 is 21, and this cannot be reduced further, so that's what that multiplication of fractions gives you. 1 over 2 times 2 over 3 times 3 over 5. We can cancel out the 2's and the 3's and we end up with 1 over 5. When we take a look at 5 2/3, we have to convert this to a proper fraction. And the way we do this is we multiply 3 times 5 and add 2. So 3 times 5 is 15 plus 2 is 17 over 3. And that's where we get this term here. 3 1/2 is 2 times 3 plus 1 over 2, which is 7 over 2. And that is where we get this term. So 17 over 3 times 7 over 2 gives us 119 over 6. This is the final fraction that has been simplified. Let's take a look at this multiplication here. 3 times 2 is 6 plus 2 is 8, so that becomes our 8/3. We have 5 times 4, which is 20, plus 3 is 23 over 5. When we multiply this, we get 184 over 15. Now if we divide 15 into 184, we're going to get 1, we're going to get 2, so we're going to get 12 with 4/15 remainder. Let's look at these examples of fractional multiplication. We have 2a over 3b times 5c over 4a. And what we can do right away is we can cancel out the a's, divide 2 into itself, those once, and there goes 2. So this is going to give us 5c over 3 times 2b, which is 6b, and that's our answer here. Now the next example is x over x plus 2 times x squared minus 4 over x cubed. If we multiply this numerator times this numerator, we get this. We multiply this denominator times this denominator, we get this. But you'll remember that x squared minus 4 is a difference of squares, which can be written as x plus 2 times x minus 2. We can cancel out the x plus 2 and divide this x and get x squared here, and we end up with x minus 2 over x squared as our answer. This one here is involving two expressions, x squared plus x minus 2 times 2x squared minus 3x minus 9 over all of this. In this case, if we factor this, we're going to get x minus 1 times x plus 2. If we factor this, we're going to get x minus 3 times 2x plus 3. If we factor this, we're going to get x minus 1 times x minus 3. And if we factor this one, we're going to get x plus 2 times 2x plus 3. At this point, I think you can see we can cancel out the x minus 1s, the x plus 2s, the x minus 3s, and the 2x plus 3s, and end up with an answer of 1. When you divide a fraction, it's really the same as multiplying by the reciprocal. So AB divided by CD is the same thing as AB times the reciprocal of CD, which is D over C. And this gives you AD over BC. Let's take a look at a couple of examples of division, way of expressing it here, where we have x over y divided by x plus 2 over y minus 1. Now by multiplying by the reciprocal, we just flip these over and multiply it here, and this is the result that we get as a final result for this expression here. For this expression here, we can rewrite that as x over pi r squared x over 4, and when we flip this over, we end up with this expression here where we can cancel out the x's and end up with 4 pi over r squared. Let's look at changing improper fractions to a mixed form. For instance, if we're given 45 over 7, 7 goes into 45 6 times with 3 remainder. And we can get back the original by multiplying 7 times 6, which is 42, plus 3 is 45 over 7 to go back the other way. Let's take a look at 15 plus 2 over 5. We can break this down into 15 over 5 plus 2 over 5. 15 divided by 5 is 3, and we're left with 2/5 over. And we can go back the other way because 5 times 3 is 15, plus 2 is 17 over 15, which is what we have here. Now in this case, we have x squared plus 3 over x, which like the one up here, we can break down into x squared over x plus 3 over x. Now we can do like we did here to go back the other way. We can say x times x is x squared plus 3 all over x, and we get back our original one here. Similar fractions are ones that have a common denominator, and you cannot add fractions unless they do have a common denominator. So we have 2 over 3 plus 5 over 3. 5 plus 2 is 7 over 3. If we have 1 over x plus 3 over x, that's 4 over x. If we have 3x over x plus 1, subtract 5 over x plus 1, plus x squared over x plus 1, we end up with 3x minus 5 plus x squared over x plus 1. And if we do the rule of b squared minus 4ac, we're going to find that this is equal to the square root of 25 minus 4 times 3 times 1, which is equal to the square root of 13, which means this is not factorable, so no more simplification that can be done. To be able to add fractions like 3/8 and 1 over 18, you have to come up with a common denominator. I could simply multiply these together to get that common denominator and be able to work from here. But that would not give you the least common denominator. To get the least common denominator, you have to factor 8 into its prime components, which is 2 times 2 times 2. You would have to factor 18 into its prime components, which is 2 times 3 times 3. Then you can multiply the prime components together, 2 times 2 times 2 for 8, and then times here, but you already have one of the 2's here, so we'll just get rid of that and multiply by 3 times 3. This gives us a least common denominator of 72. Now let's see if this works. 3 over 8 is something over 72. And 9/8 is 72, so we multiply this by 9. We have to multiply the numerator by 9. 9 3s is 27. So our 3/8 is equivalent to 27 over 72. 1 over 18, if we want to make that 72, we have to multiply the 18 by 4, which means we have to multiply the 1 by 4. So this gives us 4 over 72, which is equivalent to 1 over 18. The addition, therefore, would be 4 over 72 plus 27 over 72, and so our final answer would be 31 over 72. To find the lowest common denominator of x squared plus x squared minus 1, and x cubed minus x squared, let's take a look at their factors. So for the first one, this is the factors of x squared plus x. This is the factors of x squared minus 1, because it's a perfect square, and this is the factors of the last one here. Now the rule for the lowest common denominator is you should not have any of these factors repeated. So we've got an x plus 1 and an x plus 1, so one of the factors will indeed be x plus 1. We have an x minus 1 and an x minus 1, so one of the factors will be x minus 1. We have an x times x times x, so we can get rid of one of these. So this will be x squared times this, and then it can be further reduced to x squared times x squared minus 1. And this is our lowest common denominator for this particular expression. Let's take a look at combining these two fractions together. I think you'll find that the lowest common denominator will really be the 2y times x, or 2xy. To convert x over 2y to something over 2xy, we have to multiply this by x, which means we have to multiply this by x, which gives us x squared over 2xy, which is what we have here. To take minus 5 over x and convert it, to get a common denominator we have to multiply x by 2y. So we also have to multiply the minus 5 times 2y to get minus 10y over 2xy, which is this term here. Since 2xy and 2xy are common, we can combine it down to x squared minus 10y over 2xy as our final result. If we want to take these two expressions here and add them together, what we have to do is come up with a lowest common denominator. And the lowest common denominator will be the two denominators multiplied together. So if we multiply the x minus 3 times 3x minus 2 on the bottom, we also have to multiply by 3x minus 2 on the top. Same thing here, if we want to get a common denominator, we have to multiply this by x minus 3. Again, we have to multiply by x minus 3 on the top. So you can see that here, x minus 3 times 3x minus 2, then there's your x plus 2, and your 3x minus 2 here. And again, what we have here is 3x minus 2 times x minus 3, so there's your x minus 3 here, times our x minus 3 here times 2x plus 1. When we work this down, we're going to find that we have 5x squared minus x minus 7 all over 3x squared minus 11x plus 6. Now if we take this expression here and see if it can be factored by using the b squared minus 4ac rule, we'll see that this comes out to the square root of 141, which is not an integer. Which means we can either write it as this form here in the lowest form, or we can actually write it where we put in the common denominator as a factored version here. Either is correct. When you're asked to combine and simplify something like this, you take a look at the denominators and you try and figure out can they be factored. Now the x squared plus 3x plus 9, when you do the b squared minus 4ac, you get square root of 9 minus 4 times 3 times 9, which is going to be a negative square root. What that tells us is x squared plus 3x plus 9 cannot be factored further. If we take a look at x cubed minus 27, we can work down that that's really x cubed minus 3 cubed, which can be further worked down to x minus 3 times x squared plus 3x plus 9. And to validate that that's the case, if we multiply this out, we get x cubed plus 3x squared plus 9x minus 3x squared minus 9x minus 27. And when we cancel these out, we get indeed that we have x cubed minus 27. Now you will notice that this factor here is the same as we have in our original factor here. So when we get a common denominator, the common denominator will really be x minus 3 times x squared plus 3x plus 9. Now if we look at this x minus 3, we have to multiply that by the x squared plus 3x plus 9 to get a common factor here. For this one we have x squared plus 3x plus 9, so we just have to multiply the numerator, which is x minus 1, times the other factor, which is x minus 3. For the last one, x cubed minus 27 is really x minus 3 times that, which is the same as the two common factors or lowest common denominator, so we can just take this and write it down here as it is. When we simplify, we get this expression here, and so we can take a look at x squared plus x squared plus x squared, so that's our 3x squared here. We have 3x minus 4x is minus 1x plus x is 0x, and then we have 9 plus 3 is 12 minus 3 is 9, and that's our final factor there over x minus 3 times x squared plus 3x plus 9, or 3x squared plus 9 over x cubed minus 27 is our final result. If we take a look at a mixed number like 3 plus 2 over 9, we can think of that as 3 and 2 ninths. What we do is we multiply 9 times 3 here to get 27, plus 2 gives us 29 over 9, and that is our answer. Here, 2 1/3, we multiply 3 times 2, which is 6, plus 1 is 7, to give us 7/3, and that is our answer here. If we want to add the two fractions x squared plus 5x, we have to realize that x squared is really over 1. And to get a common denominator, you have to multiply 1 times 2x. So here's our x squared here, and if we multiply that by 2x over 2x to get our common denominator, and then we have 5 over 2x times 1, which will give us a total here of 2x cubed for the first one, plus 5 over 2x, which is exactly what is shown here. For the next one, we have 2 over x plus 3 over x squared. Now in this case, x squared is already here, so to get a common denominator we have to multiply by x and multiply by x again. So that becomes 2x plus 3 over x squared, which is the answer that we have here.